Hello students, once again I welcome you all in my new video for class 8 and this is the second video from the chapter Metals and Non-Metals. In my previous video we have completed the physical properties of metals in which we have seen that metals are having a specific sign in them that is known as metallic luster, and metals are good conductors of heat and electricity, and metals are malleable, means the malleability property in which if we are going to hammer the metals, so they are going to become converted into flat sheets. And metals are ductile, means the ductility property means if we are going to stretch the metals, they are going to convert into thin wire. So external features we have seen that what are the properties on which we are going to classify the elements, as we have discussed in the previous video that till today 118 different elements are discovered by our scientists, and out of these 118 elements near about 90 or 91 elements are classified as metals on the basis of their physical and chemical properties. So in the previous video we have discussed about the physical property, and today we are going to start another property of metal, that is what? Chemical properties. So what do we mean by chemical properties? Students, you might have seen twins babies in human beings, like they are physically alike, similar to each other, but they are having their distinct features because their internal qualities are different from each other. So in the same way, whether 90 or 91 elements are considered as metals, but still they are going to react with other substances distinctively, means differently, and on the basis of their reactivity we have placed all the elements. If we are going to place all the elements in vertical column on the basis of their reactivity, so this column is known as reactivity series. Like you are observing here, at the top you are observing potassium and at the bottom you are observing platinum. So you can see very few names are here of metals. It means it is not the total number of metals on the basis of reactivity series. I have written here few of the elements, few of the metals which you are aware, you have may listen these metals in your daily life, like potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen. Actually hydrogen is a non-metal, but still to understand the reactivity series we place hydrogen at the middle so that we can know which are the least reactive metals and which are the most reactive metals. So as we are going to move at the top level is occupied by a metal that is known as potassium, and from the series you can know this is the most reactive element in this series, that is written here. And here platinum is at the base, at the bottom. It means it is the least reactive metal amongst all of these. So we will see how the metals are going to react chemically with other substances in their surrounding on the basis of their reactivity series. So first we will see how metals are going to react with oxygen that is present in the surrounding in the form of gas in atmosphere. So here you can see I have written the general reaction of metals, that whenever any metal is going to react with oxygen, the product will be always metal oxide, means metals are going to react with oxygen, and at the result they will form metal oxide. Like you can see here, zinc is a metal which is going to react with the oxygen, and when the heat will be available, zinc and oxygen will prepare zinc oxide, that is represented by ZnO. Another example is here, like magnesium is going to react with oxygen, and again in the presence of heat this will be converted into magnesium oxide. Actually an experiment is here at this standard, which we have to do in our classes. So when the usual class will run, I'll show you the experiment in which the magnesium metal, it can be in the form of magnesium ribbon, a ribbon-like structure, and when we are going to burn this magnesium ribbon, burning means what? Oxidation in the presence of oxygen. So when this ribbon will burn, it will provide a dazzling light, a spark will be generated there, and the ash after the burning process, that will be what? Magnesium oxide. So we will do this experiment in the class and you will be able to see how the metals are going to react with oxygen, and the resulting substance, resulting product is what? Magnesium oxide or metal oxide. So the next reaction is with water. What will happen if we are going to contact metals with the water? So depending on the reactivity series, the metals react with water in different conditions. As you can see here, sodium and potassium are most reactive metals. So when we are going to place sodium in water, since it is very highly reactive, it will react with the cold water also. There is no need to provide the heat to this reaction, and resulting sodium hydroxide will form, and hydrogen gas will be liberated, will be released after this reaction. In the same way, magnesium can react with water, but here, since the magnesium is less reactive than sodium and potassium, you can see magnesium is placed downside to the potassium and sodium. So to perform this reaction, magnesium and water, we have to use what? Temperature. In the excess of water, boiling water, this magnesium is going to convert into magnesium hydroxide, and hydrogen gas will be released. But one thing that you must remember is what? Sodium and potassium, these are the most reactive metals, and if they are getting any chance to come in contact with oxygen and moisture, they are going to react violently. Very violent reaction is this. It is not so easy. So, and it is also an exothermic reaction. Exothermic means after the reaction you will get a lot of heat, because exo means outside and thermal means what? Heat. So after the completion of this reaction, heat is going to release. That's why it is exothermic. And one question is asked usually from this topic, reaction with water, that why sodium and potassium are kept in kerosene. So it is just because these are very reactive metals, and they are going to react with the moisture and air at the room temperature. Even if we are going to place sodium in the surrounding at room temperature, and it is getting oxygen and moisture in the surrounding air, so it is going to react with the oxygen and the moisture, and the reaction will be very violent. One more important point is here that less reactive metals do not react with water, and the examples gold and platinum. Gold and platinum. One more question can be asked here. You have seen that the ornaments are made up of metals. Why? Because these are having their specific metallic luster, and since you all are aware about this, that we wear, or the persons wear, the ornaments of silver, gold and platinum, and they are using water daily in their life, but still no change is there, because gold, silver and platinum are what? Very less reactive metals, so they are not going to react with the water. Another reaction is what? With dilute acid. What will happen if the metals are going to react with the dilute acid? Dilute acid means what? Weak acid, in which the concentration of water will be more in comparison to the acid. So whenever any metal is going to react with acid, always metal salt and hydrogen gas will be produced. So one example is here. Whenever the sodium is going to react with HCl, hydrochloric acid, so they are going to form sodium chloride, that is the common salt, you are aware about this, and hydrogen gas will be released. In the same way, whenever the zinc is going to react with hydrochloric acid, zinc chloride, again the metal salt will form with the release of hydrogen gas. But here a question is asked, why some food materials which are acidic in nature, they are not placed or stored in metallic containers? Because food items having acidic nature like curd and pickles and citrus fruit juice, they are having acids in them, and we know that acids reacts with metal, so we avoid to keep such type of food items in metallic containers, otherwise they will react together and they will create some poisonous substances that are going to harm our body. So another next reaction is what? Reaction with bases. So generally metals are not going to react with bases, but zinc or aluminium, these two metals are going to react with bases in some conditions. And whenever zinc is going to react with, this is what? Sodium hydroxide. You can see Na means sodium and OH means hydroxide, compound of oxygen and hydrogen. So from your previous classes, this is what? Sodium hydroxide is a type of base. So whenever zinc is going to react with sodium hydroxide, a base, it is going to form its salt. The name is what? Sodium zincate Na2ZnO2, and hydrogen gas will be released. In the same way, aluminium is also going to react with sodium hydroxide, and again sodium aluminate, the salt will be formed with the release of hydrogen gas. So normally most of the metals are not going to react with the bases, but in few conditions zinc and aluminium are going to react with bases and they are going to form their own salt with the release of hydrogen gas. Finally, one more reaction is there, that is known as metal displacement reaction. Actually, displacement means to release something from one place and it is going to move out from there. So you can see here the reactivity series, like you are observing here the example zinc and copper sulfate. Copper, you are observing copper is here downside and zinc is here upside. It means what? Zinc is more reactive than copper because copper is placed downside. So a salt of copper sulfate, whenever it is going to react with zinc, zinc will remove copper from the salt and it will again form its own salt. So in the reaction you are observing, zinc is going to form zinc sulfate and the copper that was earlier in the form of salt, it is replaced from the sulfate. So such type of reaction where one metal displaces the another metal, that is known as displacement reaction, and in this reaction always a more reactive metal displaces the less reactive metal from the salt solution. And further, if we are going to react copper with zinc sulfate, since the copper is less reactive with zinc, so this copper is not going to create any chain because it is the less reactive than the zinc. So no reaction will take place. So a less reactive metal never displaces the more reactive metal from its salt solution. So that was all for today. The chemical properties of metals, like many of the metals are going to react with oxygen and the resulting component will be what? Metal oxide. Whenever metals will react with water, they will form hydroxide, metal hydroxide. Whenever the metals are going to react with acids, they are going to form their salt. Bases, generally most of the metals are not going to react with bases, but zinc and aluminium react with some bases and they are going to form again salt with the release of hydrogen gas. And in the displacement reaction, always a more reactive metal can displace the less reactive metal, but never a less reactive metal can displace the more reactive metal. So some questions can also be asked here, that why sodium and potassium are placed or kept in kerosene, or why food materials are not stored in metallic containers if they are having acidic in nature, or this what is reactivity series. So I hope this session will be beneficial for you to understand the chemical properties of metals, and you all will be able to solve any of the question if it is given from this topic. So that was all for today, and at the end of video I'll provide you few questions, few assignments related to the topic, and I hope you all will be able to solve them. So thank you all, thank you for watching me. Till then, we are going to meet in the next video. Take care of yourself and be safe.